Hi, I'm Jason Russler. I work for Vast Data, and I'm here to talk about Vast's new database and the connector that we made for Trino. I think I'm going to have to start this discussion with who is Vast, since I'm not sure anyone here is really going to know who Vast is. We're a software company. We're a software company founded in 2016, and we came out of stealth in 2019. And the specialty is large-scale, high-performance, cost-effective, all-flash storage infrastructure. The old adage, cheap, fast, reliable, pick two, is broken by Vast. We can pick all three, and I'm not going to go deep into the technologies, but the reason for this is the software itself, the advent of high-speed RDMA, low-latency networks that are commoditized, storage class memory, and read-intensive media that evolved in dropping the cost and pushing down the cost of flash. And the short version is that when you take all these things and put them together, you can get a really low cost per terabyte while keeping flash performance. So we like to say archive economics at flash speeds. Together, these technologies have been hugely successful for Vast. We've done very well in the last 4 years of business. We just recently got a $9.1 billion valuation. We have a 100% Gartner Peer Insights review. And we've been cash flow positive basically for almost the entirety of our existence thus far. The company is growing very fast. So now I'm going to talk really quick about what our infrastructure looks like, and this is important and very relevant to the Trino discussion and the connector discussion. In this particular architecture, we have data clients sitting at the top. These could be containers, VMs, hardware hosts, whatever. These are your clients for storage. They access over a network these stateless hosts in the black area that you see. That is the Vast cluster. The stateless hosts have, well, as implied, no state, but they offer all the compute and the front ends for all of our presentations, which are S3, SMB, NFS, and the database we're going to discuss today. On each of these stateless hosts is a whole bunch of IP addresses that the data clients access. Working further down the stack, you see this SCM and read-intensive NVMe enclosures. That is where all the state is housed. And between the stateless hosts and the stateful hosts, we have a high-speed, low-latency network that creates a data fabric for the stateless hosts at the top. This allows the system to scale horizontally and vertically. So you can add compute when you need more speed and performance. You can add flash enclosures or JBOFs as you need to increase the depth of your environment. So that we got that out of the way, we need to establish what is the Vast database. The Vast database is a tabular data presentation built on this all-flash storage architecture. It's not a containerized system. It's not a bunch of Parquet files being presented in a fancy way. It is an intrinsic tabular format built into the system on an all-flash infrastructure. It is a hybrid row columnar database, very similar to a lot of data warehouse applications that are out there. So you can think of it as a giant data warehousing system. It is for transacting on and analyzing structured data. It is ACID compliant, and it does analysis and transactions in one system. It has a REST API for access. You can think of it as a NoSQL type interface. And it implements filters, column function, indices, projections, and a bunch of other things you might expect to find in a data warehouse. What you're not seeing here is an SQL environment and an SQL and a execution environment where you would do joins and aggregations and analytical functions like that, which is where Trino comes in. The benefits of using this system is efficient use of compute resources, scalability, and simplicity. I'm going to drill into this a little bit. What is the point of the database? It's very fast. It profoundly reduces infrastructure footprint for our customers, and it's very simple and easy to use. It's a transactional database, truly, and there's no maintenance operations like you might have with something that layers over, like, say, Parquet files or something, where you get a lot of write amplification if you transact on it, which really limits the ability and just the whole functionality of being able to transact. I got some numbers here on the right, which are pretty arbitrary, but they're there, and these are comparisons between AWS Iceberg against Vast database in a similar hardware configuration. It's about twice as fast, And if you know anything about TPCDS, it doesn't really benefit from selectivity much at all because it's a warehousing benchmark. But we were still able to make it work twice as fast on Trino than with Iceberg. The second graph is a selectivity benchmark, and this is finding a single key out of a 1 billion row, 100 column database. And in this particular benchmark, it's 75 times faster for locating that one row on unordered, unpartitioned data. So this is just raw, nothing indexed, just pounding through columns. So the point of this is that VAST is extremely good, the VAST database, at locating data. We like to say needle in a needle stack type configurations. What this makes VAST really good for is keeping all your data. Basically, you use it like a data lake. You push all your tabular data in there, and then you do not have to curate and materialize views in order to do or ETL it to another system in order to get good performance out of your ad hoc querying or reporting or anything else. So it's simplifies your environment, and it's designed to simplify your environment. I don't want to go into this slide too much. This is a simplified look at the data structures that VAST has and houses. The point of this slide is to establish that it's not containerized. This is an intrinsic piece of the software and how VAST stores data, which is overloaded B+ tree type data structures that exist in SCM and in read-intensive NVMe, where in SCM, a lot of the little bits of data, min-max values, stuff like that are located all in very fast storage class memory. If you don't know what storage class memory is, it's a high speed, high endurance flash. It's kind of expensive, but there's a little slice of it in every VAST storage enclosure. Point here being you can locate data really quick using these data structures. So great, how do you use it? It's accessed via REST API. It's built on the AWS v4 signature system because it's out there, and it interchanges with Arrow. So basically you make an API request, it returns with the predicates and anything else you want in there for filtering the data, what projections you want, and then comes back with an Arrow object. Now, it's intended for parallel use. You don't just fire off one API request and get your stuff. You're supposed to use this to distribute across the database's key space. So you're going to potentially be sending thousands of these requests per second at the VAST cluster and then getting them back. We'll look at what this looks like with respect to Trino. You probably already know if you're familiar with Trino and you heard that right now, but we'll look at that in a second. There's no separate metadata housing for the database. This is all part of the database itself. So anything, if you're trying to fetch schema, table definition, statistics for cost-based optimizers, stuff like that, those are all housed without any additional configuration or thinking in the database. So this API is intended to be used by execution engines, and Trino was the first execution engine VAST built for this database. There are others that are running and others that are in the works, but this is the Trino Summit, so who cares? Accessing the VAST database. So this is what it looks like, in practice. You have your Trino cluster on the left. Each Trino cluster is spraying these API requests at all of the stateless hosts on the VAST end of things. These API requests include pushdowns, projection pushdowns, predicate, dereference, and column expression pushdowns to be specific. What this does is reduces the amount of data that comes back to Trino. So if you select for 10 rows, you're going to get 10 rows back to Trino that it's going to work with. This as opposed to something like if you're accessing Parquet files with Hive, where you do have what is called a predicate pushdown or a projection or a column pushdown. But the Trino nodes themselves still have to process a lot of that data in order to complete the filtering. In this case, if what you ask for is just a couple things, that is all Trino gets back. And what that allows you to do is it allows Trino to work a lot faster, profoundly faster in some instances. And even on full column scans, it winds up being faster as well. So let's look at the anatomy of the catalog. Now, this is the interesting stuff when you configure the Trino connector. You have you have connector name, whatever. That's part of it. You have the endpoint. An endpoint is configured in the catalog, points you towards one of the nodes. Doesn't matter which, just points to the VAST system somewhere, and it uses that endpoint for metadata, schema information, the statistics that we talked about earlier. Then you have a region access key, secret access key. These are all the things that you might see in an AWS or if you're configuring, S3A. Only we're not talking S3. This is just how we implemented the REST interface by overloading the vForce Industry System for AWS. Then we get into the tuning. This is the interesting stuff, and these have analogs that in the basic Trino configuration. So we have number of splits, which is exactly what they are in Trino. A split is how much we parallelize operations per Trino node and per split, and it's how many drivers you can have operating at any given point in time on data. So that's configured per node in the catalog configuration for the VAST database. Second is the number of subsplits. When a request goes to VAST, it goes along with the configuration item for subsplits, and subsplits is where it is further parallelized on the VAST side. One thing VAST has really mastered is the parallelization of operations on the compute nodes, on the front ends, in order to maximize the utilization of the SCM. SCM is hopelessly fast for most systems. You have to really work in order to get the number of IOPS out of those things that they're capable of. And the system was designed from the ground up to do that. So you need to parallelize as much as you possibly can. So what this amounts to is if you have a single Trino node configured to point at the VAST cluster, we now have, by the time it hits the VAST system, 640 splits that happen just with one node. So you multiply that by however many Trino nodes you have in your cluster, and you have a lot of splits working and working very effectively on the VAST side to locate data. The rest of this is pretty simple. So we have the ability to we have a data endpoints configuration item down here where you can point to all the specific VAST endpoints that exist on the network where we're serving data from. Or if you don't use that configuration item, it'll just use the one endpoint that you have. And so that would be an instance where if you have a load balancer doing things on your network and splitting those up. We just added as a nicety the ability to put the load balancing in the connector itself as well. So this is a connector for Trino, and it is open sourced, and it is available at this address. And so you can get it, and you can download it, and you can use it in Trino with VAST. That's actually it. I think I finished this up early. So thanks for your time and good day.